This is Scripps Cast, a podcast service of the Scripps Institution of Oceanography. Well, do you ever wonder what global warming will look like once it reaches its full potential? As it turns out, an event that may be very similar to what we're experiencing now has already happened. Last fall, a group of Scripps researchers set out to Cedar Breaks National Monument in southern Utah in search of the Paleocene-Eocene thermal maximum, a global warming event that took place 55 million years ago. It caused the die-off of many deep-sea organisms and caused the ancestors of today's crocodiles to migrate as far north as the Canadian Arctic. The team collected rocks that members hope will contain a chemical record of the event, left behind by microorganisms alive at the time. Here are lead researchers Richard Norris and Johnny Lyman to talk about their experience.
Cedar Breaks is, of course, it's a national monument, and it's a place where people go and see all these beautiful rocks and so forth. And what I think most people don't recognize is that there's also a really fascinating climate story to be had there, and that all those colorful, pink and yellow and white sediments, they were all deposited in ancient lakes and so forth, preserve a record from about 55 million years ago when the world was unusually warm.
Cedar Breaks is really, really cool to us because it has lake sediments that are made out of carbonate. Most lake sediments aren't made out of carbonate. These are a particular type of lake that formed somewhere roughly between 65 and 35 million years ago.
Cedar Breaks is notable in itself primarily because it records this record of really extreme climate events back about 55 million years ago. When we think that the surface temperatures of the world seem to have warmed by somewhere around 5 to maybe as much as 8 degrees centigrade. And over the space of maybe 1,000 years or so, or a little bit less. And then that period of really super warm climates lasted for something in the order of 150, 200,000 years. At high latitudes, things got a lot warmer, and that's of course also predicted for modern global warming too. And so we find, for example, that the Arctic Ocean was apparently a nearly freshwater lake. It was all covered with duckweed, which is this little alga that grows in people's aquariums, and that there were alligators and so forth marching around on Ellesmere Island, which is a difficult place for an alligator to make a living today because it gets way too cold in the wintertime. Not even very warm in the summertime for that matter, okay? And alligators don't like sub-freezing temperatures. There were palm trees growing around some of the big lakes that then existed in central Wyoming and in Colorado. There was in fact this whole big string of very large lakes, sort of analogous to the modern Great Lakes, about equal size, okay, stretching across Utah and up into Wyoming. And they were surrounded by tropical or subtropical rainforest, including palm trees and alligators and flamingos and things like that. So this was a very different world from what we know of today.
We may see a much larger change today than we saw at the PE boundary, but one of the nicest things that we have is the complete record of that change. In the past, we can look at the whole thing from start to finish and see, all right, the Earth heated here, it cooled here, it changed the temperature distribution in such and such a way, and we can look at that whole thing. And we don't have that luxury now with the climate. We can't see the future specifically, so what we want to do is look at as close an analog as we can find in the past. We take each one of the samples that we took in the field and we bring it back to the lab, and we have a very small drill. So we drill into the rock, and the fine powder that's produced from that drill, we take and weigh a very small amount, something on the order of 200 to 600 micrograms, and put that in a glass vial and flush that vial out with helium to remove all the atmospheric CO2 that's originally in there. Then we add 100% phosphoric acid, and that reacts with the calcium carbonate to produce CO2 gas. We analyze that CO2 gas on the mass spec and look at the carbon and oxygen isotopes from that CO2 gas. And between all of the samples, we'll have a complete record of carbon and oxygen isotopes, hopefully across the entire Paleocene-Eocene boundary.
And the main point that we're looking for is to see how rapidly in this lake record the onset of this event takes place. Is it a couple hundred years, or is it a longer period of time? We have the beginning of it. We can see how rapidly temperatures rose 55 million years ago. And we can see how that rise in temperatures played out in terms of changing the nature of the biota and causing species to migrate here and there, in some cases species to become extinct. And changes in the acidification, for example, of the ocean, which is becoming a major concern to many biologists and geologists. So the Paleocene event, it may or may not be, the same kind of process that is going on today, insofar as that, undoubtedly, of course, the mechanism of global warming was different back then than it is now. But it seems to have involved this major input of carbon from whatever source, we don't know, into the atmosphere and the ocean. And in that respect, it is analogous to what we're doing now.
We're just going to have to learn that as these changes occur, there's going to have to be adaptations. So something to look at with the Paleocene-Eocene boundary is that things didn't die off. In fact, mammals flourished as a result of this. But they didn't flourish without other organisms dying off. So we need to kind of keep in mind that there will be a balance and there will be adjustments to be made.
What is very striking to me is that the acidification that we see of the oceans in the Paleocene-Eocene event is both frightening and, in some respects, hopeful. It's frightening because if it's sort of a potential analog for what we're doing now, and if the amount of acidification of the oceans that took place in the Paleocene-Eocene event happened today, that we could anticipate these very widespread extinctions of modern biota, things like corals and clams and the little microorganisms that I work on in the oceans. But it's also hopeful in the sense that there was this widespread survivorship of species. There was a lot of changes in the distribution of species, but there was very little extinction except in the deep sea. And that suggests that either this PE event, this Paleocene-Eocene event, wasn't as severe as what we're going to do today, or that the species were simply more robust to dealing with those sorts of changes in the acidification of the ocean than we think they are. And I think the lesson from that is that, it could potentially be really disastrous today.
Preliminary results from the trip are expected by March 2007. This is Robert Monroe for Scripps Cast.